In the problem given to us, my group used Darcy's law to calculate the permeability of a rock core sample, as well as different error percentages in measurement. Permeability is the measurement of the ability of a porous material to allow fluids to pass through it. The permeability is directly related to flow rate, as Darcy discovered. My group's goal was to use Darcy's equation in a function to calculate the permeability, which is significant in the petroleum engineering field as it allows the engineer to determine the likelihood of oil being in an area and if the land should be drilled. Here you see the equations that will be used in our project to run the code. At the top, we have Darcy's law equation, which will be used to calculate permeability, which is K. Q equals flow rate and A is the area. Next, we calculate the resolution uncertainty in another function. We have the standard deviation. We have the combined uncertainty. We have three different equations to be used to calculate error propagation, and we chose the first one. And then we have the percentage error in measurement. For our algorithm, we first start off with input data given to us. This is experimental data provided in the lab experiment that we will use as a database to form our calculations from. Next, check the data to ensure that the pressure max doesn't exceed 75 psi. To do this, we use conditional statements and we use a for loop with an if loop and a while loop inside. And for this, it's efficient as it allows the code to make any corrections in the user's input data before running the whole program. Next, we check the data to ensure that the pressure minimum is not less than 35 psi. And again, we use for, if, and while loops. We then check the data to ensure that the time range is from 65 to 165 seconds. In the process of all of this, if you input data more than 3 times, you will get an error message and the program will terminate. Before you reach the 3 times, you will get warnings to correct your input data. We next convert all input data to CGS units. We calculate the average time for each flow rate setting, and we calculate the average pressure drop for each flow rate setting. Next, you calculate the average flow rate for each flow rate setting. Finally, in step 2, calculate the area of the measuring cylinder, which will be used to calculate permeability, which is the next step, in which we call on the function permeability. In our last task, we have to calculate error. So we call on our functions, resolution, standard, combine, and error propagation. We then call on error propagation to calculate percent error, and we calculate average error. Finally, we display our given data in a bar graph that shows the relationship between permeability and flow rate setting, and we create a line graph for the average flow rate versus average pressure. On this line graph, we create a trend line of best fit for the average flow rate versus average pressure. We then display all calculated values of permeability for flow rate, percentage error for each flow rate, and the average permeability and average percentage error. We will now run the code. So first we're asked to please replace the values with pressure less than 75 psi. Use 73. Next, please replace the values with pressure greater than 35 psi. Let's use 55. Next, it asks you to please replace the value with time values between 65 and 165 seconds. Let's use 104. We are now given all our statements about the calculated value of permeability for each flow rate setting. So flow rate setting 5 is negative 2.23 times 10 to the negative 10. For flow rate number 7, it's 1.49 times 10 to the negative 10, and so on. You're also given the calculated value of percentage error for each flow rate setting, 4, 5, 7, 9, and 11. Next, it calculates the average permeability calculated 3.72 times 10 to the negative 11, and the average percentage error, which is 6 times 10 to the negative 13%. Here is the first bar graph given. It is of permeability versus flow rate setting. Next, we have the line graph of average flow rate versus average pressure with the best fit line and the equation calculated. Let's run the program one more time. So it asks you to please replace the values of pressure less than 75. Let's go with 73. Here it asks you to please replace the values with pressure greater than 35. And here's where the efficiency of the code comes up. It allows for the corrections if there is error up to 3 times. Using the conditional statements, it checks all data inputs to make sure they are within bounds. For example, if we do not go within bounds, so let's do something less than 35, 3 times, you will get an error message as you have entered an incorrect value more than 3 times, and the program terminates. This ensures that all data points are within the dimensions to calculate permeability and the error use. Another efficient thing about our code is that it uses functions to calculate each variable, which can be seen here. Here's a combined function that we call on. Here is the error propagation function we call on. We have to ignore the negative sign in this as it requires an absolute value. Next, we have the permeability function. Then we have the resolution function. Finally, we have the standard function, which also uses for loops. Determining permeability allows engineers to see whether or not wells should be drilled. If porous rock is found in an area, it will lead engineers to drill as chances of finding oil or gas are high, as it shows that they are trapped within the pores of the rocks. This code would allow engineers to input all the data accumulated from the field to determine whether the permeability signifies petroleum or not. It could save time and money by predicting the chance of finding black gold. This will allow students to visualize one of the most important things that goes into drilling wells as a petroleum engineer. A huge limitation is the code is only able to run with data inputs within the dimensions of the experimental data given. However, with more experiments done, data could grow and provide a larger database to calculate permeability and error percentages